So today we're doing exercise 2A.2, which is solving by completing the square. We're going to look at 4 methods of solving quadratics. So we did one yesterday called solving via factorisation. Today we're going to do completing the square. Now we touched on this right at the end of our last unit when we were talking about circles, and we were going from the expanded form of a circle back to the factorised form. And I said, not a skill we're going to assess, because it comes up in the next unit. This is where it's coming up, completing the square. Now again, it will start pretty basically, but then we'll get into some more complex ones that involve us completing the square, and we have a number out front and so forth. Okay, so to start with, we've got x plus 3 squared is 7. So this is an equation. We can do anything we want as long as we do it to both sides. And what we're going to do here for this equation is start by performing the square root of both sides. Alright, so I'm doing the square root here and the square root here. And what that does for us is the square root gets rid of this square. Okay? So that's going to become x plus 3 on the left hand side. We've got rid of the square. And on the right hand side we have the square root of 7. But it's important for us to know the square root of 7 is going to be plus or minus the square root of 7. Okay, so whenever we perform a square root, there's a positive or a negative solution. We're considering both. And then to get x by itself, we're going to subtract 3 from both sides. So if I take away 3, I'm going to have minus 3 on this side, and then we have plus or minus root 7. So the solutions to this quadratic, the solutions that make the left-hand side equal to the right-hand side, is minus 3 plus root 7, or minus 3 take root 7. It's absolutely fine to express it like that, full marks there. Here I'm just demonstrating there's 2 answers. There's 2 values of x that make this statement true. You substitute that in, the left-hand side equals the right-hand side. Okay, on to example B. Alright, our first step is going to be to square root both sides. Alright, so if we were to do that, we would have this. Alright, but there's an issue. What's the issue? Can't square root a negative number. This has what we call no real solutions. If you go on to do specialist maths, you'll find that there are roots of negative numbers. They're imaginary numbers. That's why we call it no real solutions, although there are imaginary ones. For our purposes, we don't need to consider imaginary solutions. So whenever we have, this is the rule, whenever there's a square root of a negative number, no solution, can't do it. Okay, so anytime you have the square root of a negative number, no solution. There's no value of x that's going to make that statement true. Okay, on to C. Now, you might be thinking, yep, okay, here we go, square root both sides, but we can't do that yet. We're breaking this down. We first need to get rid of the 2. We want to get the squared term by itself in order to perform the square root. So our very first step is going to be to divide both sides by 2. So we'll have x take 3 is equal to 9 divided by 2. Alright, now when we're talking about, well, in methods, we generally prefer to keep things as an improper fraction. You can express it as a decimal if you want. Yeah, we'll just keep it like that. So we have x take 3 squared is 9 and 2. Alright, now we can square root both sides. So that's going to give us x take 3 is the square root of 9 on 2, plus or minus of it. So my brackets here, 1 squared. And then we're going to add 3 to both sides to get rid of this minus 3. Now, I'm going to talk very quickly about what we call surd operations, because these will pop up for answers in the textbook, although it's not a skill you're required to do for this unit, because we don't do it till later in the year. So as far as surd operations go, this is probably the only one we need to know. If you have the square root of a divided by the square root of b, it can be expressed as the square root of a on the square root of b. Okay? So in this circumstance, you could manipulate this answer a little bit further, right? It could be 3 plus or minus the square root of 9 on top of the square root of 2. And we know the square root of 9 is 3, right? So it could be 3 plus or minus 3. The square root of 9 is positive, is 3 on top of the square root of 2. So this answer here and this answer are the same. The textbook will probably write them like this, okay? You're going to get full marks at this stage, all right? We're not required to know the surd operations. Just be aware that the textbook may take them a bit further, okay? Ask me if you're unsure, but it's a pretty straightforward rule. Not required to know it just yet. Okay, so let's move on then. That's A and B and C. So now we're on to D. So here this one's a little bit different because if we look at these three examples, all of them already had a completed square. They already had a perfect square. Over here we don't. We're presented with a quadratic in general form. Right? One way we could write this right would be like this, hey? X squared plus 2x take 5 is 0. All right, that would be the same expression, just written differently, right? Now, let's look at the process for completing a square. So, if we flip back just a page, rearrange so that only the constant, all right, that means the number, only the constant is on the right-hand side. Complete the square by adding b on 2 squared to both sides. So I better talk about that quickly first. A quadratic, if this is the quadratic, it has this form, ax squared plus bx plus c. All right? Now, a is the coefficient of x squared. It's the number in front of x squared. In our circumstance here, a is 1, b is 2, and the constant term is minus 5, right? A, b, and c. We can extract that information from the general form. What's our second step say? Add b divided by 2 squared to both sides. All right? We're always going to do that because we're always manipulating it so that we can complete the square. All right, so the first one I'm going to do in an excruciating amount of detail, and then from then on we're just going to show we've done it to a perfect square, so it's going to expect it. All right, so I've got x squared plus 2x, and I'm going to leave a little bit of space, and equals 5. That's the expression I've got here, right? This is the equation I've got. And we're going to add b, here b is 2, we're going to add b divided by 2, okay, that's the b value, always divided by 2 squared, to both sides, right? We can do anything we want as long as we do it to both sides. Okay, so then I'm just going to process this a tiny bit. One way we could write this 2 times x is we could write it as 2 times x times 1. And then over here, 2 divided by 2 simplifies to 1. All right, when we're doing bed maths, we would do the operations in brackets first. 2 divided by 2 is 1. So we've got this 1 squared here. And over here we've got 5 plus 1 squared. All right, I've set it up like this. This is where I'm talking about the excruciating detail. Because what we've done here, what we've got is a perfect square. All right, I might even write that underneath it. A squared plus 2ab plus b squared. All right. We can recognize a corresponds with x, all right, and b corresponds with 1. And because it follows that, and that expanded perfect square is equal to this factorized perfect square, we can factorize this expression. We can complete the square. So we've got a corresponds with x, b corresponds with 1, so it simplifies to x plus 1 squared. All right, that's what's on the left-hand side. On the right-hand side, we're going to have 5 plus 1, we're going to have 6. Okay, so that's a skill we've sort of looked at before. We're completing the square, right? You can check that this is equal to that by either doing some FOIL or by using the perfect square expansion rule. What you'll see is that is the same as what we have on the left-hand side. Okay, and then it's just what we've been doing. We're going to square root both sides, plus or minus square root 6, and then subtract 1. Here we have x squared plus 6x equals 2. Alright, so our first step is to add b on 2 squared to both sides, right? B, in this circumstance, if we think a is 1, b is 6. Alright? And so I've said we always add b divided by 2 squared to both sides. 6 divided by 2 squared. Alright. So that becomes x squared plus 6x plus 6 divided by 2 is 3. And 3 squared, I'll just write it like this, 3 squared. Alright, so from here, you can jump straight to the perfect square. You don't need to write it out like this. We've manipulated it on purpose so that we can factorize it, okay? If you can go from there to there, we recognise that's the x, that's where the 3 is going, we've got x plus 3 squared. Over here, 2 plus 9, 11. Square root both sides. We have lots of 3's here, don't we? Okay, any questions yet? Alright, so hopefully we'll go through all the examples, hopefully that just keep reiterating the process. It'll develop a bit of confidence and competence with it. X squared plus 5x plus 2 equals 0. Okay, here we've got the number on the right hand side. Let's think back to our process that we had listed. Step 1, make sure the constant is on the right hand side. So we're going to start by subtracting 2 from both sides. Okay, next we need to add b divided by 2 squared. Alright, so here our b is 5. So we're going to have x squared plus 5x plus b squared on b divided by 2. Okay, this is a perfect square. We've set it up so that it has to be. So this is going to factorise to x plus 5 on 2 squared. Alright, and I'm going to process these fraction operations because I want to emphasise these skills, right? Here at this stage, right, you've got your calculator in this test. You can just whack that in your calculator. Nonetheless, the manual processing of it is an important skill for us to have. Okay, should be good at it. So we have minus 2 plus 5 divided by 2 squared. What? I'm just going to focus on that part. Minus 2 plus 5 on 2 squared. Okay? Think about bed mass. We have to perform any operations in brackets first. 5 divided by 2. We could simplify it to 2.5. Alright? Or we can keep it as 5 on 2. I've said keep things as improper fractions. That's generally our preference. Next is exponents. So that 2, that square, needs to distribute to the numerator and the denominator. So we have minus 2 plus 25 on top of 4. Alright, I'm squaring the top, I'm squaring the bottom. Now, if I want to add these numbers together, minus 2 plus 25 divided by 4, they need to have the same denominator. So I need to rewrite minus 2 with the denominator of 4. That's minus 8 on 4. Minus 8 divided by 4 will give you minus 2. And then we have plus 25 on 4 hanging out here. Alright, they have the same denominator, which means we can bring them together. What's it? Minus 8 plus 25 on top of 4, which is 17. Positive 17. Alright, so all of it, if you put that in your calculator, here's what it's going to simplify to, but that's my thinking and reasoning behind it. Anyway, the point of that, right, the point of that is to show that this is a positive number, which is good because we can square root it. And remember, if it's a negative, there's going to be no solution. Here we have a positive number, positive 17 on 4. So we're ready to square root it. So we have x plus 5 on 2 equals plus or minus the square root of 17 on 4. And then we're going to subtract 5 on 2 from both sides. Okay, 4 marks there. But again, I'm just going to show you a couple of different ways it could be expressed. All right, you've got to get in the habit of understanding there's different ways of expressing answers, even though they're the same number, the same value. So one way we could write this, I've said, using surd operations, is it's root 17 on the square root of 4. And we know the square root of 4 is 2. So it's minus 5 on 2 plus or minus the square root of 17 on 2. And now they have the same denominator, so you could collect. It could be minus 5 plus or minus root 17 on top of 2. Alright, so that's one way of writing the answer. I'm going to give you 4 marks there, that's fine. Okay, so that's F. Alright, we'll move on to G. X squared take 4x plus 1. Alright, we're going to subtract 1 from both sides. To get the constant over the other side, we're going to add b divided by 2 squared. Now, whenever we add b divided by 2, notice here, if I'm going to write it up, this is good. Got me easy to know. Alright, notice how b is negative 4. Alright, doesn't matter because here, when we add it, we're squaring it, right? And whenever you square a negative number, that's going to make it positive. So we don't even need to consider the negative when you add it in, okay? You don't even need to consider the fact that the coefficient of the x term is negative. All right, so we're adding it to both sides. 4 divided by 2 squared. We'll chuck this vector after this. All right, well, let's write what it simplifies to. We're going to have x squared take 4x plus 2 squared equals minus 1 plus 2 squared. This is x take 2 squared. That's where the negative comes in, right? Look at the perfect square expansion. If everything's positive, it expands to a perfect square that's positive. If there's a negative here, we need to have the negative there, right? So we have the negative here, and so that means we've got the negative version of the perfect square. Minus 1 plus 4, positive 3. Square root both sides, and root 2 over. Alright, h. We have 3x squared plus 6x equals 4. Alright, so the constant term's been moved over. We need to factorise the perfect square by completing the square, but we've got a problem. It's not a mnemonic quadratic, it's trinomial, is it? We've got this number out front. So that means we need to get rid of it. We always get rid of that coefficient first. So we're going to divide both sides by 3. Alright, so I'm going to go divide by 3, divide by 3. Alright, so what that's going to do here, we've got x squared plus 2x, and over here we're just going to have this number 4 on 3. Okay, next we will complete the square by adding b on 2 squared to both sides. Alright, so we divided by 3. Alright, we've made it a mnemonic quadratic trinomial, and now we're ready to complete the square. Here we go, we've got x plus 1 squared equals, and I've got 4 on 3 plus 1, 7 on 3. Alright, do the fraction operations, break it down, make it have the same denominator. 1 is 3 divided by 3, 4 plus 3 is 7. Alright, or you can use a calculator, but get good at fractions. Square root both sides. And then move the 1 over. Excellent. Okay, so that's what we're planning on dedicating the lesson to today. Look, I've dedicated a whole lesson to it, but if we do find we're finding it okay, we can move on to the next one. I'll come around, let's see how you went with all the 2A.1. Thanks very much. Perfect.